All right, so this video will focus on 7.4, and the first thing we're going to do is kind of go through and look at the legs. So I have like, for each one of these, you're going to go through and draw a triangle, and we'll do like 30 by 40, and you have to figure out the hypotenuse, right? So I have 900, and I have 1600, and so this is 2500. So the square root of 2500 is 50. And you're going to do this for all of these. You're going to go through. So pause the video and try to solve these. All right, so here are your various answers as you draw them out. What we want to do is we want to find the decimal approximations of the square roots that are not rational. We have to figure out what rational even means today. So that's kind of what part of our activity will be. So Archimedes went through and he tried to figure out at one time if either of these fractions were equivalent to the square root of 3. And what I want to do is I want to figure that out. So let's go through it, and what I want you to do first of all is just figure out what is 265 over 153. All right, so let's go through here, and let's take 265 divided by 153. And I get this number here, 1.73. Just write that down so I remember it. So I'll put down 1.73. Let's keep going. I think there's a little bit more to that, actually. 2026. 2026. Okay. And the other one is going to be 1351 divided by 780. And for this one, it looks like a very similar number, doesn't it? 1.732051. So this is a 5-1 at the end. So let's put 5-1. So everything else is the same. And it says, are either of these numbers equal to the square root of 3? Well, the way that you figure this out is I'd actually go in and I would do the square root of 3. Or what I could do is I could take these numbers. I can take like 1.732026, and I'm going to square it, right? Let's see if I have a square here. I'll say squared. And if I look at that, that answer doesn't get me to 3, does it? It's very close, but it's not quite 3. So let's try this other one. 1.732051. Oops. And let's do the same thing that I just did. And I'll say squared. And that one's a little bit too much. So the square root of 3 is somewhere in between these two numbers. And they're very close, aren't they? So as it goes out, it's somewhere here. And I have to find out where it is, which is kind of hard to do. So I have that, and basically what we're trying to do is it says try to find the approximation of 3. And this is really important just to understand how these irrational numbers work. If I go through and I do the square root of 3, I get this number here, right? And I'm going to write this number down. I'm going over to the side so I don't lose it. So I'm going to have 1.7325080757. Well, that's what shows up on the calculator, right? But if I plug this number back in, I plug in 1.7325080757, and I square this, I don't get exactly 3. I get a little bit either over or under. And the reason why is because your calculator can only go out so many places, and then at the last thing it truncates, meaning it rounds up or down. And this is where things are problematic. Because if I would take this and I would subtract 3 from it, right? I don't get 3. And I should be getting 3. If I would take my square root and multiply it by 2, it should equal 3. So what this is basically showing you is that this will go on forever. There's no number that I could really put down and square. I mean, it'll go out forever. And that's the problem with this. And it says the value of square root of 3 is between what two integers? Well, it's between integers is between 1 and 2. Closer to 2, and then I want to know is it which one of these is it closest to? Is it between 1.7 and 1.8, 1.72 and 1.73, 1.731 and 1.732? Well, let's look here. If I just do let's just take the upper end of these things, okay? And the upper end would be like 1.732, and if I square that, my number is not even big enough. It's not even 3 yet, right? Let's take the upper end here, 1.73, 1.73, and let's square it. And it's not big enough yet, right? So then let's try the last one, 1.8 squared, and that one finally is a little too big. So between all these things, this is the one that it's in between. These two aren't large enough. So then the next thing it says is, what is the length of the diagonal? Well, this is 1. I don't really know what this is, but I do know that it's a square. So if this is 1 here, this has to be 1 as well. So this would be 1 squared and 1 squared. So let's just write this down. So 1 squared plus 1 squared equals c squared, right? In this case, I'm going to have 1 plus 1 equals c squared. So I have c squared equals 2. And the square root of 2 is right between 1.41. And it keeps on going. It is an irrational number. And you're probably saying, like, what is this irrational number that Mr. Thoreau keeps talking about? It's this right here. So think about counting numbers. We call them natural numbers. So like 1, 2, and 3 are natural numbers. Okay? It goes on forever. But they're all whole numbers, right? Well, natural numbers. Whole numbers is when I add the number 0 to that set. So if I have 0, 1, 2, 3, now I'll have whole numbers, and all the numbers that are larger than 0, that are like 1, 2, 3, are natural numbers as well. So these kind of go together. And then finally, when I add negative numbers to the mix, now I have integers, because it's either positive or negative whole numbers, right? Because it includes 0. And then when I include rational numbers, that's when I start including fractions as well. So if you think of a number line, when it includes all these fractions, I have rational numbers on there. The integers are the positive or negative whole numbers, right? Whole numbers include 0. Natural numbers are 1, 2, and 3. And then I have these things called irrational numbers, which is what we're talking about today, which are like the square root of 2 or pi or something like that. And these are all irrational numbers. Collectively, this circle of irrational numbers that go on forever and this collection of rational, integer, and whole and natural numbers are all considered to be real numbers. Now, you're probably thinking, yeah, I know real numbers, but what would be the opposite of real numbers? Well, imaginary, which sounds crazy. But think about this for a second. If I have negative 15, the square root of negative 15, there's nothing that I can multiply by itself to get negative 15, because a negative times a negative is a positive. Later on, you'll learn that there's these imaginary numbers that make this true. We're just not there yet. So let's look at this and try to figure out what these things are. So the square root of 12 is going to be irrational, because if I figure this out, it will go on forever. Again, when I plug it into my calculator, it appears like I have a number. Let's just check it out. I'll just do 12. And I'll do. It appears like it ends, but it really doesn't. This truncates. So this goes on forever. It's irrational. So it's not a perfect square. I'll just keep on going. This one here, it repeats, right? So if a number repeats, this is called a rational number. And the reason why it's rational is because it either terminates or repeats, and that is rational. This one here, negative square root of 9 is an integer. And the reason why it's an integer is because this is a perfect square, and it's a negative. So it's got to be a rational or a rational number. And there it is. 72 divided by 4 is a natural whole number, because it equals 18. And then pi is irrational, because it goes on forever. So I'll classify this one here. What would this be? This one here would be an integer, because it's going to be a perfect square and it has a negative. This one here, the cube root, this will be irrational. This one says estimate square root of 71 to the nearest integer. So let's think about my squares, right, for a second. What times what is close to 71? Well, 8 times 8 is 64, and 9 times 9 is 81. So let's just put this down here for a second. So if I move this over, if I put 8 times 8 is 64, and 9 times 9 is 81. It's in between here because I want 71, right? Well, how far away is 64 from 71? And if I think about that for a second, it's got to be like right around 7. This one here is 10 away. If they were exactly the same distance away, it would be 0.5, right? It'd be like exactly in the half. It'd be like 8.5. But it's not. It's actually closer to this one. So I'm going to say it's like 8.4. So let's just try that and see what we get. So if I take 8.4 and I square it, I get really close to 71. And then it says estimate the square root to the nearest integer and 10 first, this one. So this is going to be between 2 and 3, but it's really close to 3, right? I mean, really close, because 3 is 9. 2 is 4. So I'm going to say it's like 2.9. This one here, it's going to be between, let's see, 3 and 4. 3 is 9, and 4 is 16. So that's going to be like right in between the two, right? Well, closer, I guess a little bit closer to the 16. So it'd be like 3.6. So just take a look at these for a second. I have like negative 3.6. This one here is close to 25, right? So negative 5. But it's really close. That's why I'm saying negative 4.9. This one here is really close to 110, or because 10 times 10 is 100, or 11, which is 121, right? So it's in between those two. And it looks like it's right in the middle, so that's why it's 10.5. This one here, I'm just going to plug in this number. I'm going to have 51 divided by 3. And I'm going to do the square root of it. So this is 17. So I'll do square root of 17. I know that's really close to 4, because 16. So I'll say like 4.1. And let's see what we get. Okay, so about 4 inches, or 4.1. This one here says if you plug in, I want to know this periscope. This formula that I have is if I take 1.17 times the square root of whatever the height is. So if I take a 6 and I plug it in, and I multiply 1.17, we'll see what we get in a second. And then if I take 1.17 and then the square root of 3, we'll see which one is, can you see twice as far? So let's look here. So if I take the square root of 6, so I'll just do 6 equals times 1.17, and I get 2.86. And then this one over here is the square root of 3 times 1.17. And I look at this number and I have 2.026. Is this twice as far? It's really not. If it was twice as far, it would be not the same number of 2, right? It would be like 4. And it's not. It's in the same category. So it is absolutely not going to be twice as far. This one here says which number is greater. So I have 4 1/5. Or if I look at this, this is between 4 and 5. Going to be closer to 5 though, won't it? So it's got to be more than 1/5. So I'd say square root of 23 is larger. This one here, which is a greater number, well, square root of 10, of course, is going to be larger than the square root of negative 5, right? So this one here, negative 2 in the square root. So this will be larger because it's going to be a smaller number, closer to 0. This one says the area of a circular mouse pad is 64 inches squared. All right. So let's look here. So of course, negative 5 is negative, so 10 is positive. That's why I said it's greater. 23 is further to the right. Square root of negative 2 is to the right of this, so this is going to be the larger one, about 5 inches here. And then you can only see 3.7 miles when I do that. Finally, it says, how do you describe the approximately square root of 5? Well, it's between 2 and 3, really close to the 2, so like 2.1. And then I guess my last one would be this one here. Put it in order from least to greatest. I know that this has got to be between 6 and 7, really close to the 6 though. So I'll put down 6. This right here, this would be equal to approximately 33. And the square root of 33 has got to be less than this one here, right? So I'd say it'd be this, then this, then this. And there we go.